Hello, everyone. Good morning, afternoon, evening. Dear authors and invited guests, welcome to Technical Session 5G. Myself, Priyanshi Goyal, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 9th International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2025, Bangkok, Thailand. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Bangkok, Thailand, and the virtual event is being held through Zoom today and tomorrow, that is 5th and 6th of April 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for question and answers. On a 9-minute mark, I'll raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any queries or updates, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session, Dr. Manoj Joshi. Dr. Manoj Joshi is an assistant professor in Department of Computer Science and Engineering at Sir Padmapat Singhania University, Udaipur, India. His research expertise lies in data mining and information systems. He has contributed to academia through research publications, teaching, and mentoring students in advanced computing domains. Now, I would like to invite the session chair, Dr. Manoj, to kindly deliver a welcome remark and set the tone for the session.
So, a very good morning and good afternoon to all of you, all the participants. And thank you, Priyanshi, for such a nice introduction. So, I'm very thankful to the organizers of this conference, ICTIS Thailand 2025, Information and Communication Technology for Intelligent Systems. Okay. Uh, this platform is very good for the researchers and for the all the upcoming, you can say, people who are interested in research and development. So I again appreciate your participation in this particular conference. And the session, as madam has told, that this session will every participant will be given 10 minutes, so please be stick to the time and try to include your important points which you want to showcase in this particular presentation. Okay, so over to you, madam. We can start, okay, the presentation.
Sure, sir. Thank you so much. Just a second. Yes. Uh, Now inviting the first, I'm sorry. Now I would like to invite the first author for today, Pradanya Vishwas Chitrao, from to present us her paper titled "A Consumer's Perspective on the Elements That Led to the Development of Digital Payments in India During COVID." Do we have you here with us, Pradanya? Do we have any of the team members with us? All right, since the presenter is not here, we'll be moving forward. I would now like to invite Mrunal Jadhav to kindly present a paper titled Blockchain-Based E-Waste Tracking, a Comprehensive Survey and a Proposed Framework. Do we have you here with us, Mrunal? Are any of the team members present? All right. Let's get to the third presenter. I hope the person is available. Kindly inviting Sharif Rakibul Rayhan to present his paper titled CNN for Evaluating the Suitability of Ovarian Cancer Patients for Bevacizumab Therapy. I'm sorry if I pronounced that wrong. Do we have you here with us, Sharif?
Yes, I'm here. Thank you.
Yes, I'm really sorry if I pronounced it incorrectly. Over to you.
No worries.
We'll just stop presenting. Yes, your screen is visible. You may start.
Perfect. Thank you. Is the presentation is showing, right?
Yes, 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 it's
Okay,
visible.
perfect. So our topics is on CNN for evaluating the suitability of ovarian cancer with the bevacizumab therapy. Hi, I'm Sharif Mohammad Rakibul Rehan, who is a student of Independent University of Bangladesh, and I have other co-authors with me, Mr. Khandakar Waliur Rahman, Istiaq Asad, Ataur Rahman, and Mahdi Hassan. So today we'll be discussing on the problem statement, our methodology, the result we found, and some comparative analysis, and finally the conclusions. So basically, the ovarian cancer poses actually significant health challenges globally. Often it is diagnosed at the advanced stages. The early stage is crucial for effective treatment, but it is very difficult to detect earlier. With the bevacizumab therapy, it offers a potential for the late stage ovarian cancer patients, but it required an accurate patient selection. The challenge is to predict the patient's response to the bevacizumab therapy from the histopathology images. Uh, in the methodology, we actually used almost over 4,200 histopathology images, from which with the 3,000, we actually trained our data sets. And for the rest, we actually used for validating and testing. In the process, we actually resized our images with 224 by 224 pixels. We used an augmented using fast AS functions where we randomly rotated the pictures with 45 degrees. We zoomed the pictures 1 to 1.1 times, and we changed the lighting, wrapping changes, and up to 20%. We also employed the pretend ResNet 18 model, initialize the fast AI CNN learner. And from the learning curve, we found that actually the value is around 0.0014. As we found the value was 0.0014, we use a learning rate 0.001 for the training, and we actually trained with 40 epochs with the learning range of 0.01 to 0.001. Then we actually fine-tuned with 20 more epochs with the smaller range, like 0.001 to 0.0001. With this result, with this training, actually, we found actually very good result where actually we found the model have a 98.2% accuracy in the validation. With this test data set, we found that actually we have a 97.6% accuracy with a very minimum loss of 2.8% with a fine tuning. The confusion matrix also demonstrated a strong true positive, which is a more than 97% true positive and less than only 1% false negative, and approximately 3% false positive found, which actually showcase the model's performance very good. Also, the ROC, we actually found it's up to, on the top left corner, and AUC was also indicating, showing 1, so which actually indicated a perfect classification. Finally, we actually also tried VGG16 model as well. And in compare with ResNet 18 and VGG16, we found that actually ResNet 18 demonstrated a very superior performance in terms of accuracy, precision recall, and F1 scores. We also tried to compare with some other paperworks with a similar type of works. Many of them actually use hybrid model, Inception V3 model. More or less, we actually found that ResNet 18, our model actually performed very good in accuracy. So the AI-driven models hold a promising and promising in predicting patients' response to the therapy. The indicator of the AI in clinical decision making can enhance the personalized cancer treatment, and we have a target of future studies to aim to explore broader application to improve the reliability. Thank you. If you are interested to learn more about our research, please scan my QR code and keep in touch.
Thank you. Are there any questions?
Anybody from audiences want to ask question from? Okay, we can move to the next one.
Thank you.
All right. Can you please stop presenting?
Yes, I'm trying to actually. Um, Stop presenting. Aha. Got it. Right.
Thank you. Moving forward, I would like to invite Abhinaya to kindly present her paper titled Comparative Research of Artificial Intelligence Techniques for Predicting Autism Spectrum Disorder, Challenges and Future Enhancement. Do we have you here with us, Abhinaya?
Shall I proceed, ma'am?
Yes, please. I'll stop presenting. Yes. Yes, your screen is visible. You may start.
Good morning, everyone. Myself, Abhinaya, pursuing my PhD degree under the guidance of Dr. W. Rosevarena in the Department of Information Technology, Bharathiar University, Coimbatore. And the title of this work is Comparative Research of Artificial Intelligence Techniques for Predicting Autism Spectrum Disorder, Challenges, and as well as the Future Enhancement. And my paper ID is 960. These are all the contents this presentation covers: introduction, problem definition, literature review, comparative study, methodology, result and discussion, challenges, conclusion, and references. Introduction. Autism spectrum disorder is one of the neurodevelopmental disorder. It can be identified using some of the characteristics like lack of eye contact, delayed speech, and lack of verbal and non-verbal communication. And they usually get disturbed by if the sequence or schedule has been changed, and they usually play in a particular order, and so on. It can be assessed and identified using some scales like Indian Assessment of Autism, and modified checklist for autism toddlers, and autism behavior checklist, etc. And children's life is at risk because of delayed identification. If it is identified in earlier stage, then the particular children can be treated with relevant therapies and interventions so that the children can lead a normal life so that uh, we come to know that early identification and intervention plays a significant role in autism children's life. And due to lack of awareness, the affected rate is increasing day by day. To overcome this scenario, recent advances in artificial intelligence techniques have become promising in early detection and treatment. Artificial intelligence is a simulation of human intelligence, and here machine learning techniques has been used for predicting autism. And problem definition: in India, 1 in 39 children are affected by autism spectrum disorder, and the main objective of this research is to suggest the best AI techniques to identify autism in earlier stage. And these are all the literatures. And Anupam Garg et al. Have proposed an explainable deep learning framework to predict autism. And here they have been used 4-layer deep learning model to classify ASD and non-ASD children. And in this Indian scale assessment of autism has been used as the questionnaire. And Jay Sankar Balasubramaniam et al. Have been implemented machine learning techniques to identify autism. And the main objective of their work is to develop an application tool for predicting autism. Here they have been used machine learning 5 machine learning techniques in order to predict autism. And they have been developed IAGT tool with 37 questions. Linda et al. Have demonstrated machine learning techniques for predicting autism. Here they have collected all the medical histories, and in the study they have the data set is splitted as 20% as tested and 80% as trained, and here they have applied 10 folding techniques for tuning and machine learning techniques like SVM, gradient boost, etc. And here they have suggested that by collecting several mental and non-mental conditions from a family can predict autism risk. And Chen et al. Have described that autism in younger children can predict it using machine learning techniques. Here, the real-time data has been used in the study, and machine learning techniques like LASSO, LR, RF shows the promising result in predicting autism for ASD children with several age categories. These are all the literature which have been motivated to do this research. And comparative study, here we have compared four research papers. Here in first papers, Asma et al. Have implemented XG Boost, SVM, DT, SGD, RF, SG Boost 2.0, which is the proposed algorithm. Here they have been used, and here Q chart has been used as the data set, and here it produces the best and the best finding is SG Boost. And in the next one, the next author, Jay Prakash et al. Have used CAS data set and used MLR technique with various age categories, and shows the and suggests that MLR is working better when compared to the rest of algorithms. And in and the next one is Mohammed et al. Have been used SVM, DT, RF, LR, KNN has been used as a machine learning techniques. Here QChart 10, AQ10 data set has been used, and here LR shows the best findings for predicting autism. And the next one is Chen et al. Have implemented DT, SVM, RF, SG Boost, LR, GMM, K-means as the machine learning techniques for predicting autism. Here they have been used AQ10 as a questionnaire data set. And in the methodology part, from the previous one, it shows that SVM and LR shows the best result when compared to the other techniques. And here, additionally, in this work, we have added random forest as well as the decision tree machine learning techniques has been implemented. And the workflow, the figure 1 represents the workflow of this proposed work. The first one is we are loading the data set from UCI, Kaggle, as well as the real-time data set has been used. And the step 2, which is data pre-processing. Here we have been in data pre-processing, we are handling the missing values, and in feature extraction part, PCA, which is principal component analysis, has been used for feature extraction. And the fourth step is we are splitting the data set as 70% as trained and the 30% as tested. And the machine learning techniques has been applied to train the model. And the performance evaluation of a model can be is tested by using confusion matrix. And the next one is we are getting the 20 attributes as an input from the user, and we are comparing with we are feeding it to our trained model. After that, it produces a result as either autistic or non-autistic. In result and discussion part, in this proposed work, we have been used 3,320 data set has been used, and among that 70% data are trained and 30% are tested. And here the performance matrices has been evaluated by using the confusion matrix. Confusion matrix is nothing but the statistical form to predict the overall model's effectiveness. And here we have taken the parameters as accuracy, precision, and recall. Here we have compared SVM, random forest, logistic regression, and decision tree. From this, from this table 2, it shows that SVM works. SVM shows 82.3% as accuracy level, and the figure 2 represents the graphical representation of performance matrices of a proposed model. Challenges in the challenges in predicting autism is we cannot predict autism's earlier stage
This is a
as a
gentle
single.
1 minute reminder.
Okay, ma'am. A single test cannot predict autism's early stage, and predictive models can suffer due to overfitting or and underfitting. Collecting data is quite risky due to confidentiality. Conclusion and future enhancement. In previous one, they have suggested that SVM LR shows the best results when compared to the other results. Additionally, we have compared DT and random forest has been used in this proposed work to enhance accuracy level. As previously informed, as previously said that 3,320 data has been collected and processed based on the Indian scale assessment of autism, as well as the modified checklist for autism toddlers has been used as the assessment scale. In this proposed work, it proves that SVM shows a better accuracy level as 82.3% in predicting autism, and where other shows that RF shows 79.4% and LR shows 80.6% and DT shows 78.2%. In future, large data sets can also be applied in this model, and optimization algorithms can also be used to enhance the accuracy level, and deep learning algorithms also can also be used for predicting autism with a higher accuracy. These are all the references, and thank you.
Thank you, Abhinaya. Are there any questions?
Yes, Abhinaya, this side Dr. Manoj Joshi.
Yes, sir.
You are getting my voice?
Yes, sir. Yes, sir.
Okay. So, Abhinaya, that one question comes when I saw your paper and the findings is that why you have used tenfold cross validation while analyzing this, only tenfold cross validation?
Sir, tenfold cross-validation testing has been used in previous paper. Here, we don't use tenfold validation process here, sir.
So, which process you have used in analyzing?
Principal component analysis as the minimum and maximum value, sir.
Okay, that is actually for feature extraction. Okay,
Yes, sir.
principal component. Okay, so
For tuning, they have been used, sir, in that proposed in that work.
so why PCA then? Why PCA? Why principal component analysis? Why? What is
Sir,
the base of
when
choosing?
So when compared to the other technique, it works better for feature extraction processor for identifying the patterns of data, sir.
So how many attributes were there in your data set?
Sir, in our attributes, 20 attributes have been used, sir.
So what does that then feature extraction has done? The purpose of feature
Sir,
extraction is to reduce the number of attributes
yes, sir.
and select the
We
appropriate.
have been used behavioral and social characteristics, which is mentioned in Indian assessment of autism scale, sir. In
Okay.
that, we have selected only the behavioral part.
So what does then feature extraction has done? It has reduced the data set, or it's not changed the data set. What that
Sir,
PCA
sir,
component
in
has done?
previous question, we have totally we are collecting 42 as the question is, sir. And after feature extraction, we are using 20 attributes.
Okay. Okay, then just a suggestion from my side to
Okay,
you.
sir.
Just whenever you are discussing literature review, do mention the years with the
Oh,
authors, the
sure,
years,
sir.
okay,
Sure, sir.
so that we can identify which author has contributed what in that particular area. Okay,
Okay,
so
okay, sir.
do make sure that add the years with the author name. Okay, in literature review. Okay,
Okay, sir. Sure, sir.
okay, thank you.
Thank you, sir.
Thank you, Abhinaya. Moving forward, I would like to invite BAE Madhushika to kindly present her paper titled Enhancing Identity and Access Management Security with Adaptive AI and ML based AI and ML based authentication, a critical review. Do we have you here with us, Madhushika? Do we have any of the team members with us? All right, since there's no response, we'll be moving forward. Uh, I would now like to invite Disanayak to kindly present her paper titled Enhancing Regulatory Compliances and Efficiency of Decentralized Equity Investment Platforms, a Critical Evaluation. Do we have you here with us?
Yes, ma'am. Yes, ma'am. Can I share the screen?
Yes, just a second.
Okay.
Yes. Yes, your screen is visible, and I think you're on mute. Please unmute yourself. Yes, now you may start. You are again on mute, Binali. Yes, your screen
Now,
is.
yeah, can you hear me?
Yes, we can hear you. Please start.
Okay. Good morning, everyone. I'm Binati Disanayaka, and I'm excited to present our research title Enhancing Regulatory Compliance and Efficiency of Decentralized Equity Investment Platforms, a critical evaluation at ICTIS 2025. This study was a collaborative effort with RL Karunavira, PAUD Herath, PHP Jayatilaka, Ms. Dilini Kulavansa, and Dr. M.F.M. Ferdhouse from the Faculty of Information Technology at the University of Moratuwa, Sri Lanka. Today, I will guide you through our findings, highlighting key challenges, insights, and future directions in this dynamic field. This is the overview of today's presentation. Um, let's move on to introduction. The landscape of decentralized finance is expanding rapidly, and but regulatory compliance and operational efficiency remain as significant challenges. Our motivation for this study starts from the need to develop a secure and legally compliant decentralized investment solution. In this presentation, we will critically evaluate existing approaches and discuss a potential future direction to enhance these platforms. To better understand the problem, let's first look at traditional equity investment model versus decentralized alternatives. Traditional systems are well regulated but centralized and also heavily rely on intermediaries. Because of that, there are many issues raised like data breaches, operational failures. Blockchain has enabled decentralized finance, simply called DeFi, eliminating traditional financial intermediaries through smart contracts based financial services. Decentralized finance offers tokenization that enhances market accessibility and liquidity, while 24/7 operations allow global participation beyond traditional stock exchange hours. Even with these benefits, decentralized equity markets are tackling major challenges such as regulatory compliance, security threats, and interoperability limitations. Previous studies have explored various blockchain models, but challenges still persist, highlighting the need for improved solutions. In our critical review, we mainly focused on research on these two areas: regulatory compliance, efficiency. These concerns not only affect platform trust but also hinder widespread adoption. Addressing these issues is crucial for sustainable growth in decentralized finance. As decentralized equity investment platforms gain traction, regulatory challenges become a major hurdle. Let's explore the key challenges in this space. First, there is a lack of regulatory clarity and fragmentation. Different jurisdictions have varying and sometimes conflicting regulations, making it difficult for decentralized platforms to ensure compliance globally. Second, AML and KYC compliance challenges arise because decentralized systems inherently prioritize privacy, making identity verification and anti money laundering measures harder to enforce. Third, market integrity and manipulation remain a concern. Without proper oversight, decentralized markets can be vulnerable to fraudulent activities such as pump and dump schemes and insider trading. Fourth, consumer protection concerns exist as investors may not have the same safeguard as in traditional financial systems, leading to potential risk in case of fraud or platform failures. Fifth, jurisdictional and cross-border regulatory issues create complexities as transactions in decentralized platforms often involve multiple countries with different legal frameworks. Lastly, integration with traditional financial system is still a challenge. To achieve widespread adoption, decentralized platforms must find ways to comply with existing financial regulations while maintaining decentralization. Addressing these challenges is crucial for the mainstream adoption of decentralized equity investment platforms. Now let's come to efficiency. While decentralized equity investment platforms offer promising benefits, they also face significant efficiency challenges. First, transaction efficiency can be a hurdle. Unlike traditional stock exchanges with optimized infrastructure, decentralized systems, especially blockchain based ones, can experience network congestion and delays, affecting trade execution speeds. Second, cost reduction is expected in DeFi systems, but in reality, high gas fees and network cost can make transaction expensive, particularly during peak activity periods. Third, security and transparency remain concerns. While blockchain offers transparency, vulnerabilities such as smart contract exploit and potential security breaches can undermine investor confidence. Finally, liquidity and asset management present challenges. Decentralized platforms often struggle with fragmented liquidity, making it harder to match buyers and sellers efficiently. Additionally, managing tokenized assets across multiple chains requires robust interoperability solutions. Addressing these challenges is key to improving the efficiency and adoption of decentralized equity investment platforms. In this study, we explored how DAG-based blockchain architecture can enhance the efficiency and regulatory compliance of decentralized equity investment platforms. Traditional blockchain models often struggle with scalability, high transaction fees, and regulatory adherence, making them less suitable for large-scale financial applications. However, DAG-based systems offer asynchronous transaction processing, high throughput, and real-time validation, which can significantly improve efficiency. A key advantage of this approach is the integration of decentralized identity systems, which enhance compliance with Know Your Customer and anti money laundering regulations. By embedding regulatory compliance into systems using smart contracts and cryptographic identity verification, we can address security threats and regulatory concerns, making decentralized investment platforms more acceptable for mainstream adoption. Despite these benefits, challenges remain. Interoperability with traditional financial systems is a major issue. Ensuring smooth asset transfers and regulatory oversight requires further research. Additionally, the practical scalability and real world implementation of DAG based model in large scale financial transactions still need validation. Moving forward, addressing these challenges will be crucial to realizing the full potential of DAG-based block decentralized equity investment platforms. As part of our future work, we are developing an equity investment platform on a DAG-based blockchain integrated with decentralized identity system to measure empirically its efficiency, security, and regulatory compliance capability. We will compare our system with an Ethereum based equity investment platform and assess key performance indicators, including transaction velocity and cost saving. We believe this research can contribute significantly to regulatory compliant decentralized finance. This is the reference list. Thank you for your attention.
Okay, so basically it was a review paper, I think. You have
Yeah,
just
yes,
taken
yes,
it.
sir.
So what do you propose for the developing countries? How to implement this decentralized approach? What are the barriers actually for the developing countries?
Uh, the main barriers would be regulatory compliance because many countries has different uh, legal environments. This is the major barrier that we are facing. So,
Okay, thank you from my side. Okay. Okay.
thank you, sir.
ඉවරද? ප්‍රශ්න අහන්නේ නෑනේ. මේ ඩිජිටල් නෑ ඔක්කොම ලොග් කරලා ඒවා ගන්න. පුළුවන්.
Kindly mute. So the next participant.
Sure, sir. Thank you so much for the presentation. We'll be moving on to the next presentation. And we have Sunita EV with the paper title Fine Grain Bug Localization in Software Projects Using Code Graph. Ma'am Sunita, are you available in the session? Well, I guess she's not here. Any of the co-authors of the paper? Okay, so we'll move on to the next one. We have Naresh K with the paper title Low Cost Surveillance System for Crop Using IoT. Sir Naresh, are you here in the session?
Yes, ma'am. Yes, ma'am. We'll proceed.
Yeah, you may please begin with your presentation.
Good. Shall we start, ma'am?
Yes, your screen is visible. You may start.
Yeah. Thank you. So our title is Low Cost Surveillance System for Crops Using IoT. So my co-author Kunj Goyal is with me. So I just give the highlights of our work. So our work suggests suggest a model to protect
Please,
cultivated
please
crops.
make it full screen. Okay.
Full screen, sir.
Yes, so that it is clearly visible to us.
Naresh sir, can you just put it in presentation mode?
Yeah, it's in presentation mode. Can you please check if it has gone into presentation mode on your side?
No, it has not gone into presentation mode.
Yes, slideshow. Slideshow.
Yeah, slideshow.
Go to from beginning.
Yes.
Yeah. Thank you. So as I said, our work suggests a model to protect cultivated crops from animal intrusion and theft of ready-to harvest crops by human. So here the highlights of our model is we are doing the edge computation. So we avoid the sending the surveillance frames to the cloud. Instead, we perform the processing of the frames at the edge level, and then we just send the notification to the farmer if any type of animal intrusion or theft of ready to harvest crops by human is given as a notification to the farmer so that he can take necessary action. Now I just give my presentation to my co-author, Kujwal. He will start the presentation. Thank you.
So good morning, everyone. We will start with the introduction. So basically, the problem many farmers are facing in developing countries, most of the Southeast Asian companies and African countries, is that small farmers are constantly being threatened by the different pests, different animals different locals that are attacking their farms, and the technology being used to deviate them from this problem is too high of an engineering, or it's too costly of an engineering. Like if you say about drones and all. So that are not feasible to implement in small farms or the farmers who take farms on rent. So we have come upon an idea to make a low cost system. So the key take points or the key takeaway notes is it's a low cost system, first of all. Second of all, it's edge AI based, so no nothing is processed in cloud. Thirdly, it's scalable, highly scalable system. So if a large scale farmer want to implement the same system, it can easily implement it. And fourthly, it is not harm. It doesn't provide. It doesn't do any harm to the animals or the livestock. If the farmer has livestock and livestock enter the farm, so the traditional method of the electrical fencing usually harm the cattle, but in this system, it doesn't harm the cattle. The the next thing I would like to come upon is the related work or the challenges in traditional surveillance. There were high operational costs. Like I said, there were drones being used, which are if you say in today's world, agriculture drones cost 25 to 30,000. So small scale farmers couldn't purchase those or couldn't use those in their farms. Moreover, continuous human intervention was needed to see over the farms if anything is there in the farm. And usually in India, farmers live a little far from the farms, especially in India. And thirdly, extensive power consumption. If you talk about drones or any other CCTV systems, they work on AC power and they couldn't be operated by solar panels. So these are extensive in power consumption. Moreover, the system is based on cloud. So cloud processing is still a dream or it's still a heavy workload for many. So the related work, most of the papers that you see here, they either work through PIS sensors, which are not working on which are not working on ML models or detecting through ML or cams, but they are using some kind of sensor like PIS sensor, IS sensor, or something like that, which can give false detections as well because they don't know what is in front of the sensor. Then they only know that yes, something is there, but they don't know what it is. Secondly, the second problem, the second miss point the papers has is that they are cloud based. But if the things are cloud based, there is a chance of latency in the system, which is avoided by the system we have developed. So to encounter all these problems, we have developed a system. So this is the design model of the system. Actually, there is one thing known as ESP32 CAM. It is in India, it is easily available for rupees 3 to 400 rupees per node. So the ESP32 CAM can be powered by solar panels also. So multiple ESP32 CAMs are placed in a field and a network is generated by the router. So all the ESP32 CAMs get connected to the router through Wi-Fi protocol in a mesh network type, and the router is powered by PoE through Raspberry Pi 5. Now, Raspberry Pi 5 is used here because it is easily available, but if the farm is big, we can shift to other SBCs like Jetson, Xavier, Jetson Oren, or Intel. Anything we can shift to, and the Raspberry Pi 5 then detects any animals in the frames being sent by the ESP32 cam over the network, and then if there is any animal or if there is any anomaly, the Raspberry Pi 5 sends a WhatsApp alert to the user of the system. So here is the implementation. So the blackish thing you can see is a power bank. I am powering the ESP32 cam from the power bank for now. The thing with the PoE injected in is the router. You can see it's generating a network. And the last thing is the Raspberry Pi. It only needs a uh, 5 amp power at 5 volts. So all the three components are low power and can be easily powered. So here are some metrics for the system. So we have detected that around 93% of the detections are accurate. Moreover, the false positive rate is low because the model being trained is not being trained by us. It's already being taken from a very renowned company known as Ultralytics, which works in YOLO models. You only look out once. Moreover, average response time is of 7 seconds from detecting to sending the message. Network latency only accounts for 3 milliseconds, and if we are going with the Raspberry Pi 5, we can support up to 5 ESP32 cams. But if we are going with more number of cams, we can shift to other SBCs. And with the field deployment, we can deploy it in any kind of fields through sticks or through any of the things which can uh, put the cam high in the sky. So when showing this image, it has detected horses. Though it has detected two horses, but still it has sent the message that a horse being detected in the field. In the second thing, one person is being detected, and the same message has been sent to the user of the system. So conclusion is basically that the system can be refined more to detect pests and other plant diseases, and also to monitor soil, because a network is already generated, and it is viable for small scale to large scale farmers. So it doesn't depend whether a farmer has a small scale farm or a large scale farm. Thirdly, the system ensures that autonomous detection is being happened without the reliance of the system on cloud services. Because in farms, if there is a network drop or if there is a latency, the whole farm is gone. Uh, Fourthly, the use of WhatsApp provides an instant alert mechanism. So within 7 seconds, you get an alert, and you can rush to your farm to save it from any kind of intrusion or any kind of animal. Thank you, and that's all we have. Any questions, please?
Yes. This is a very very good topic, and my one question is that did you have done any kind of cost estimation?
Yes, sir. Actually, we have a so there is one table in the research paper also. So I will give you an approximate cost. So each ESP32 cam costs 3 to 400 rupees according to the quantity you order, and the Raspberry Pi costs around 6 to 7,000 rupees. And the router in today's era, it costs around 7 to 800 rupees. So without changing the code base, we can implement more number of ESP32 cams. Just we have to add the node. So it is highly dependent on how much ESP32 cams you are putting in the field. So if, for example, if you are putting three ESP32 cams, so 3 into 300, 900 rupees plus 6,000 rupees, 6,900 plus 1,000 rupees miscellaneous cost including the router. So around 8,000 rupees. And that's a one-time cost.
Okay, so basically your costing majorly depends upon this area of the
Yes,
farm
sir.
also. So
Yes, sir.
based on that, any comparative analysis, if the
Uh,
area is, so you can do that. Okay, so that the clear picture of the cost analysis would be then analyzed when you can vary
yes,
the
yes, yes.
farms, and then total costing can be analyzed. Okay,
Yes.
thank you from my side.
Thank you, sir. Thank you.
Thank you so much. Um, just a second. Moving forward, I would like to invite David Babao to kindly present his paper titled MedBlock, a decentralized blockchain and IPFS-based framework for secure electronic health records. Do we have you here with us, David?
Yes.
All right, just a second, I'll stop presenting. Yes, can you share your screen, please?
Is my slide visible?
I'm sorry, yes, it's visible. Can you put it in presentation mode?
It's in presentation mode.
Am I the only one who is not able to present it in presentation mode? Can someone confirm? Um, uh, all right, I think let's start. Yes, thank you. Please start.
Good morning, everyone. My name is David Popov from the Department of Computer Science and Engineering. Today, I'll be presenting on my project paper, that is MedBlock, a decentralized blockchain and IPFS-based framework for secure electronic health records. Firstly, I would like to forward my gratitude to the organizers for giving me the time to present my paper today. Thank you so much. Uh, Firstly, to get on with my presentation, let us first look at our contents. So to start off, I'll be giving an introduction of our project. And secondly, our objectives and our work done, then our proposed model and the results of which what we have achieved, and finally our conclusion and our references. So in today's world, health records are very important in the medical field for analyzing and diagnosing patient cases. In such cases, this we have traditional health record system. That is, they keep health record in files or in Excels. These are centralized systems. That is, they are very prone to loss or inconsistent in different healthcare centers, or they are hard to retrieve when going from one healthcare to another healthcare center. So to rectify these problems, uh, our project try to create a secure and decentralized medical network where we can share patient and doctor records and hospital records and for easy retrieval and storing of these data. Now, our project has a system. This system has a distinct user interface for patient and doctor. And in this interface, we are integrating with blockchain for its data security and immutability, where we are storing the patient and doctor's data, and the IPFS for storing the huge data like the hospital records for easy storage and retrieval. Now, our main objective of our project was to counter the disadvantages faced by traditional healthcare record management system. That is, with the use of blockchain and IPFS, we would like to make a decentralized system for easy retrieval and storage of health records. So to ensure data integrity and accountability in the health record management, and to improve accessibility and efficiency in storing and retrieving patient data through our system, and also to facilitate collaboration among different medical centers to share the data with each other, and also for patients to access their data from any medical centers. And lastly, to access the past records of patients or past records of other patients for more enhanced diagnosis of medical cases. Now, these are the work done. We have developed a user case for like patient and doctor, where the patient and doctor can interact with the system, and the integration of blockchain technology and IPFS to the system. Now, the deployment and interaction with blockchain network. Here, we have deployed a smart contract in the blockchain. So, like this smart contract helps in checking every data that are entered into the system, and generation of unique ID for patient and doctor. So whenever a patient or a doctor registered to our system, the blockchain send back a unique ID for the patient and the doctor, and saving the medical records of patient in blockchain, saving the medical records of patient in blockchain and the patient data and the doctor data in the blockchain, and saving the hospital records in the IPFS and accessing the data from the IPFS with the use of the IPFS hash, and accessing the patient and doctor data from the blockchain. Now, this is our proposed model. We have the Ganache blockchain, where we are deploying the smart contract, the IPFS, where we upload the hospital records, and the user interface for patient and doctor. So whenever a patient or doctor is not registered, they first register to our system. So when they're registering, they enter some data. And while they're entering these data, the MetaMask, which act as a wallet for fake eaters, they trigger the transaction. So with the help of Web3, the smart contract deployed in the Ganesh blockchain will also be triggered. During such time, every data that are entered in the patient or doctor when they're registering, the smart contract will check all these data, and when they accept these data, they will send back a return ID, a unique ID for the patient or the doctor. And that's how we registered in our system. And if a patient or doctor want to view their records, all they have to do is enter their ID, unique ID, and the smart contract will retrieve the their data from the blockchain. Now, if they want to access the hospital records, they will also put the hospital ID, and from the smart contract, they will take the hash from the blockchain. They will take the hash of the hospital record and go to the IPFS, and using that hash, they will extract the hospital records. Now, these are some of the results. This for registration. This is similar even for patient registration. So when they're registering, they will enter the data like name, gender, date of birth, address, phone number, and specialization and password. Now, when they press on register, the MetaMask will trigger the transaction. The smart contract deployed in the Ganesh blockchain with the help of Web3 will check all these data, and when all these data are checked and saved in the blockchain, they will send back and return unique ID for the doctor. And this for login. When the doctor want to log into their account, they will enter their ID, unique ID, and their password. Now, in this same case, the smart contract will check the ID and the password, and if they match with any of the data entered in the blockchain, they will send back. They will take us to the new web page where um, the doctor can view records or update records or view hospital records. Now, this is the result of retrieving a patient data. So when a doctor or a patient want to retrieve their data, all they have to do is enter the ID, patient ID. And when they enter the patient ID, even here, the smart contract will check the ID. And when the ID match with any of the data in the blockchain, they will send back the data and it will be displayed on the web page as such. Now, this is the example of our hospital records which are saved in the IPFS. So when the doctor wants to access the hospital records, they will have to go to the hospital record and enter the hospital name or the hospital ID. Now, when they do such, our system will take the hash of the IPFS from the blockchain, which is saved here, and then take this hash and upload it to the IPFS. Now, with this hash, they will upload it to the IPFS, and when they upload it, the IPFS will return us with the hospital record. Now, these hospital records are constantly being updated. Whenever a new patient arrives to the hospital or a doctor do a patient checkup, every checkup will be updated to the record. As such, date of treatment is given and the patient ID and doctor age and every diseases are written here. Now, we can also do one more thing in this record, that is we can filter out. So like when by pressing the headers, we can enter the parameters and enter parameters and search for certain patient or for certain date or for certain diseases. Now, our main goal has always been providing a solution to the problems faced by traditional record management system. So our MedBlock has succeeded in such a way to provide security and immutability to healthcare records. That is through the use of blockchain and IPFS. Yes, there is potential for future development like encryption of every data that we enter into the blockchain or when we're entering any data in our system, or the use of OTPs, SMS OTPs, like when the patient or doctor are entering into their account, an OTP can be sent to the SMS so that it could be more secure. So like there's a continuous focus on enhancing data security in our future works. Now, these are the references which we took for our project. Yes, our project has said for our project goal is to rectify the challenges that is faced by traditional healthcare record system, which is a centralized system, by providing a decentralized system where we can share health records from one center to another center without facing the problem of the system being destroyed and the data being lost. So thank you so much for taking your time to listen to my presentation. Thank you.
Thank you, David. Are there any questions?
Yes, David, this side, Manuj. Okay.
Yes, sir.
Uh, this is a new approach, which is centralized blockchain approach. What do you think about the implementation challenges which might be there with this approach as compared to traditional record keeping methods?
Uh, One of the main problems that we will face when we're implementing this is like the cost. Since right now, my project partner and I and our staff, we have been using like fake ethers for
Okay.
the blockchain. So like if when we are actually using the Ethereum for the blockchain, it will cost a lot. So like we will have to use another blockchain or another method to solve this problem, sir.
Okay, you work on that area, try to do the comparative analysis with some of the traditional uh, hospital information management systems which maintain the records and other things. Okay. Okay,
Yes,
thank you
sir.
for my side.
Thank you, sir.
Thank you, David. Moving forward, I would like to invite Siva Kangni to kindly present her paper titled Nurturing Young Innovators Best Practices in Implementing Design Thinking in Early Childhood Education, a systematic literature review. Do we have you here with us?
Yeah, I am here. Can you
All
hear
right.
me?
Yes, I can hear you. You can now present.
I'll just quickly share my screen, just confirm if you could see it.
Yes, please.
Is my screen visible?
Yes, your screen is visible. You may start.
Okay. So, a very good morning to everyone present here. My name is Shivakami, and I'm a research scholar at Amrita School of Business, working in the area of management. So, I'm very honored to be here in digitally meet you all. So, today I would like to present my paper on nurturing young innovators, best practices in implementing design thinking in early childhood education, a systematic literature review that's been done. So this was actually guided by my supervisor, who is Dr. Suresh. And so let's just move on to the next slide. So the agenda for the today's presentation would go with the introduction, followed by the research gap and the objectives of the study, and also the methodology that we have employed, and the findings of the study, the future research directions that we have identified, and followed by the conclusion and the limitations of the study. So let me just give a quick introduction about what is the background of the study and how this popped in my mind. So something that struck me was, how do we nurture our young innovators for to develop the skills that is necessary for the 21st century skills. So in recent years, we face a lot of complex challenges that have become more challenging for us to face. So there has been a stronger push to inculcate a very innovative and evidence-based solution for facing those challenges. So one such promising solution is, of course, design thinking. So design thinking is which promotes innovation, empathy-driven learning, creativity, problem solving, collaboration. These are some of the essential skills that is very much necessary to nurture in the future ready learners. So this also prepares them to tackle the real world challenges that they'll be facing. So um, to define design thinking, it's been widely used in product innovation. It is rooted with that. Design thinking is a human-centered approach to innovation that draws from the designer's toolkit to integrate the needs of people, that possibilities of technology, the requirements for business success, which was defined by Brown, CEO of EDO, who actually coined design thinking. So this has been got traction in education after the implementation in Stanford D School. So after that, it has been seen widely in education. It's been used in integrated into all levels of education, primary, secondary, and higher secondary education. And there are also growing body of research on that. It has also been integrated into wide disciplines like STEM, literacy, social sciences, arts, and environmental education. So here we could see that we are moving from the conventional education methods, which primarily focuses on the cognitive abilities, where most of the social, ethical, and all the other crucial skills are neglected for the 21st century. And one of those thing that we could actually use here is that it has actually brought in most of the crucial skills that is needed for early childhood education. So why it is important to study early childhood in early childhood education is that there is a wide research gap in that, because most of the studies have covered in the higher secondary education and the primary education levels, but they have failed to explore more on the early childhood space. So early childhood, according to UNESCO, is the period between birth to 8 years of age, which is actually a critical phase of brain development, and it presents the unique opportunity for early education. So this is actually an critical period to instill the habits of inquiry, empathy, experimentation, and this lays the foundation, strong foundation for the children to face the and prepares them academically, and also to face the emotional well-being that they'll be facing. So, this paper addresses the critical gap by reviewing the existing research on design thinking in early childhood education, especially from the lens of best learning practices and teaching practices. So, based on this research gap, the research questions here are: what are the best practices for implementing design thinking in early childhood education? How does the design thinking influence assessment practices within the early childhood settings? So, which actually covers the educators' side, and how has the implementation of design thinking impacted the learning environment of students and the educators in early childhood education? So, this covers the outcomes of the implementation of design thinking. So for this a thorough literature review, we have employed a systematic literature review methodology by using the Prisma protocol, which is preferred reporting items for systematic review and meta-analysis. So this ensures a rigorous, transparent selection process that's been done while we select the papers. So firstly, we started with a comprehensive search of on the Scopus database, so where we have found 2,199 articles, which was roughly and also the reason why we chose Scopus database, the sole source for choosing that was because it has the high quality, high academic rigor, and also the credibility is very more, and also it makes the research process more transparent, and it can be replicated in future researches as well. So it was a strategic choice to choose that, and also wide range of keywords were used on the terms of early childhood education, um, wherein we covered all the age groups that fit into the age group of 0 to 8. As we could see, we have used preschool education, preschool, nursery, early primary, lower grade, primary grade. We have covered all the possible keywords that would cover early childhood education. And with respect to design thinking, we have also used design based learning, because some of the literature, the past literatures have been using design based learning as a replica of design thinking. So from that, we were able to get research papers from the years of 2013 to 2025. So here we could see that only there is a very recent momentum on this area. So which actually brought in the interest to do more research on that. So after excluding the uh, based on the title, keywords, and abstract, we were able to screen 65 articles. So on that, based on the inclusion and exclusion criteria, which widely was based on 11 articles were removed because they were not they were being errata, retractions in the reviews, editorials, and conference proceedings. 2 articles were from the languages other than English, and 12 articles were based on education, but it did not involve design thinking. And 15 articles did not cover the area of early childhood education, but it was covering up something very general. So after this inclusion and exclusion criteria that's been applied, we were able to finally arrive at the 25 articles, so which was considered for the final systematic review. So by applying this structured process, we were able to ensure that there is a high quality relevant studies that contribute to the understanding of design thinking in early childhood context. So based on this review, it actually also revealed us that most of the studies actually emerged only in the years of like 2022, and it went into a dip recently in the year of 2024. So a growth from findings from this study actually from this research were ranging from a growing body of research actually gave the value of design thinking in early childhood education. So even preschoolers are now engaging in open-ended design tasks, which actually builds the creativity, engineering skills, socioeconomic growth, and iterative skills. So this is one of the STEM integration is one of the best practices that we could find with respect to the children. And also on the other hand, design based learning and digital tools have shown to improve the scientific understanding in preschool settings, and these experience also
This is a
support
gentle reminder.
sorry.
This is a gentle 1 minute reminder. Kindly wrap it in the next 1 minute.
Sure. So there are also 3D design apps, 3D printers, and makerspace encourage the children to boost their language and metacognitive skills. And on the other hand, we have educational apps which imply design thinking to improve the engagement, retention, self-directed learning. The design thinking based digital storytelling would uniquely, we were able to find that it introduces social abstract concepts to preschool children, like about peace, war, and social justice. Play-based learning actually nurtures the children with creativity, cognitive development, human-centered thinking. On the other hand, we have a set of design thinking for educators. So one such is that the framework is design-based learning teacher competency model, uh, which actually brings the range of engagement, teamwork, and lesson quality. Design
I'm
thinking
sorry,
engages.
Devakami, can you please wrap it up? We have crossed the 10 minutes mark.
Sure, sure. So the other best practices for the educators are the design thinking engagement scale, multi-literate learning environments, digital project management tool, zones of participation framework, empathy-based teaching toolkit, and teacher-led BLS. So there are also some challenges with respect to lack of teacher training, curriculum misalignment, cultural constraints, assessment issues. And we have a wide range of future frontiers where we could do research on. So some of the unexplored areas are Montessori based, project based learning, natural and role based learning, and most of the research were concentrated on US, China, and Australia. So this may not be applicable to low resource setting, so we could do more research on how we could apply design thinking to unprivileged or resource limited schools to enhance inclusivity within the school. And also most of the researches were small sample sizes, and so we could do more research on employing large sample size, and most of them were STEM focused. uh, Limited exploration on humanities and social sciences, and it did not include, most of the researchers were
See,
not including infants and the toddlers. And with respect to parental involvement and other longitudinal studies, we were having a very sparse research on
I would
that.
have to interrupt. Can you just conclude?
Yeah. uh, So with this, we conclude that not just a standalone best practices would add up to add value to the educational setting. A cohesive environment of integrating all the best practices together would bring in potential possible develop the crucial skills for the early childhood.
Thank you.
Yeah.
Before taking the questions, okay, let's just take the questions first. Are there any questions?
Okay, no questions from my side also. We can move further.
Thank you, sir. Before moving forward, I just request everyone to kindly adhere to the time limit, right? Can you please stop presenting? Thank you. Right, just a second. Moving forward, I would like to invite BAE Madhushika to kindly present her paper titled Enhancing Identity and Access Management Security with Adaptive AI and ML-based Authentication, a critical review. Do we have you here with us, Madhushika?
Yeah, I'm here.
All right, I'll stop presenting so that you can share your screen. If anyone else who has missed the presentation is now there in the conference, kindly text me on the chat so that I can take your presentation forward after this one. Yes, your screen is visible. You may start.
Okay, thank you. So, a very good morning to everyone. It's a great honor to be here at the 9th International Conference on ICT for Intelligent Systems. I'm Merandi Madhushika, representing the University of Moratuwa, Sri Lanka. Today, I am excited to share insights from my critical study on enhancing IAM security with adaptive AI and MI-based authentication, a topic that sits at the intersection of cybersecurity and intelligent technology. Let's dive in. To guide you through today's talk, here are the key areas I'll be covering, starting with the aim of this study, followed by core IAM concepts, the role of adaptive authentication, and finally, how AI and ML enhance this landscape. With security breaches becoming increasingly sophisticated, static authentication is no longer enough. The ultimate aim of this study was to gain a comprehensive understanding of how artificial intelligence and machine learning can be used for adaptive authentication and how this improves the security of identity and access management systems. Now let's explore the main concepts. Let's now lay the foundation by understanding what identity and access management or IAM means. In simple terms, identity and access management is the process of managing user identities and privileges securely to ensure the right people access right resources at the right time for the right reasons. As you can see in the slide, IAM primarily involves two processes as authentication and authorization. This study is more focused specifically on authentication. As we can see here, there are four major models in identity and access management, namely centralized, decentralized, user-centric, and federated management. The centralized model often uses single sign-on technologies. For example, a company employee logging into multiple internal systems with one set of credentials. Federated model outsources identity verification, like logging into a third-party app using Google or Facebook credentials. The user-centric model involves technologies such as user-managed access, self-sovereign identity, allowing users to control their own data. With the evolution of AI and ML, hybrid and smarter models are gaining more traction. Now let's focus on authentication. Authentication is simply the verification of a digital identity of a user. It usually involves something user knows, like a password, something the user has, like a phone, something the user is, like a fingerprint,
user's location or behavioral patterns. Think of it like unlocking a smartphone. It can recognize your fingerprint, ask for PIN, or detect if you are in an unfamiliar location. Adaptive authentication intelligently combines these factors to make authentication more secure and context-aware. So, what makes authentication adaptive? In adaptive authentication, the system adjusts its security requirements based on the risk profile of the user. For instance, if a user is logged in from an unusual location or at an odd time, the system might request additional verification. This leads to the risk-based authentication, a highly discussed technique that uses AI and ML to evaluate risk before granting access. Basically, in risk-based authentication, users are evaluated by checking their activity and behavior before the authentication. Risk-based authentication happens in three major stages: data generation, risk engine processing, and authentication decision. Picture this. If you try to log in into your office system from your office, great, that's a low risk. But think if someone tries to log in from another country on new device at 3 a.m., the system will see that as a high risk and either block access or require more steps. Here is a deeper process. First, the system collects behavioral, contextual, and environmental data. Then it calculates a risk score. Based on the risk score, low-risk users proceed as normal. Medium-risk users face extra verification. High-risk users are denied or flagged. Now let's explore how AI and ML power this process. Machine learning techniques such as deep reinforcement learning help to analyze large volumes of user data to generate accurate risk scores. Artificial intelligence monitors and learns from the user behavior in real time. Based on ongoing risk assessments, the system can dynamically adjust authentication steps, offering a balance between usability and security. However, this dynamic capability comes with certain challenges. While being powerful, these systems raise privacy and transparency concerns. Adaptive authentication often collects a wide range of user data from device fingerprints to location patterns. Key issues include lack of transparency about what data is collected, uncertainty around how long it's stored, and concerns over user consent and control. Addressing this limitation is essential for widespread adoption. Looking ahead, here are some promising directions. Explainable AI will help organizations to understand the logic behind authentication decisions, improving transparency and trust. Industry-specific IAM frameworks will tailor solutions for healthcare, finance, and other sectors. AI-driven IAM standardization will promote interoperability and compliance. Blockchain integration can offer decentralized identity verification, reducing reliance on central databases. These innovations make IAM systems more secure, adaptable, and resilient on evolving cybersecurity threats. To summarize, this study explores the impact of intelligent adaptive authentication within identity and access management systems. It highlights how artificial intelligence and machine learning improve both security and user experience. And it discusses current challenges such as privacy concerns and how we might overcome them moving forward. That brings me to the conclusion of my presentation. I would now like to share the references that supported and informed this study. So here is the list of references I have used. And thank you very much for your attention. I hope this presentation gave you valuable insights into the future of secure and intelligent authentication systems.
Thank you so much, Iranti. Are there any questions?
So no questions from my side also. Priyanshi, you can continue.
All right.
Thank you so much.
Um, just a second. So that was the end of the presentations for the day. Before moving forward, I would just like to know if anyone else is there who missed the presentation and would like to present their paper. Since there is no one, I'll be moving forward.
Hello.
Yes. Hello.
Yes, my slot was 9:30 to 11:30 for presentation.
Mrinal. Right.
Yes.
Your slot was in the second. It was a second presentation. It was not 9:30. It was earlier. But no worries.
Okay.
I would like Mrinal to present her paper titled Blockchain-Based E-Waste Tracking, a Comprehensive Survey and a Proposed Framework.
Yes. Thank you. I would like to share my screen now.
Yes, please. Yes, your screen is visible. Can you put it in slideshow mode?
Yes. Okay.
All right, you may start.
Yes. Thank you so much. Good morning, everyone. My name is Mrinal Zada, and I am a final year student pursuing BTech in Computer Engineering from Pimpri Chinchwad College of Engineering, Pune, India. Uh, I'm here to present our research paper titled Blockchain-Based E-Waste Tracking, a Comprehensive Survey and a Proposed Framework. This work is a collaboration between Pimpri Chinchwad College of Engineering and Spandan Technologies, Pune, India. The authors are as follows: Professor Atul Pawar, PCCOE, India; Mr. Shrikant Kulkarni, founder and CEO, Spandan Technologies, India; Ashwini Harode, Makartuj Kamre, Mrunal Jadhav, and Sanskruti Kadmore, final year students at Pimpri Chinchwad College of Engineering, Pune, India. So let us begin. E-waste or electronic waste is increasing rapidly every year. It includes items like old mobile phones, televisions, smartwatches, computers, etc. And failing to track the e-waste properly leads to illegal dumping and improper disposal or recycling of the e-waste. This allows the toxic substances presenting in the e-waste like lead, mercury, and cadmium to leach into the soil and groundwater, contaminating the drinking water resources and also affecting the soil quality. Improper processing or burning of the e-waste also releases harmful gases and chemicals into the atmosphere, which leads to air pollution. The landfills, the e-waste in the landfills take up valuable space and also release greenhouse gases that in turn causes global warming. In addition to that, e-waste also contains many valuable materials like gold, silver, and rare earth elements, which are lost and not recovered for reuse. Right now, there are many countries and organizations that are struggling to manage e-waste properly. One of the major problem is that the existing systems are centralized. That is, the data is stored at one place. The systems are not very transparent, and also anyone can misuse or change the data at any time. We believe blockchain can be a good solution for these problems because blockchain stores data in a secure, decentralized manner, which improves the tracking, accountability, and also the trust between all the parties. Yes, so we studied various papers and systems researches to understand what work has already been done. So some use blockchain to track devices using unique IDs. Some use blockchain to provide incentives to the people who dispose the e-waste properly, and some use it to improve the recycling efficiency. So although these systems exist, the main all of these systems face difficulties regarding the high costs, the limited features, and the lack of automation. So this helped us to understand what we need to improve in our blockchain framework. So these are the challenges that we encountered in the current e-waste management systems. Technical challenges such as high energy use, scalability issues, and difficulty in managing large amounts of data are faced in existing systems. Regulatory challenges, especially when there are multiple countries, regulations and laws involved, and the data privacy concerns as well. Economic challenges such as high transaction fees, the initial costs are high, and there is a lack of awareness among people related to all of these platforms. So these are the major challenges that current systems face and that we are trying to overcome. So this is the main part of our paper, the proposed framework, the proposed blockchain-based framework. We suggest using the Polygon blockchain for to keep the costs low and also increase the number of transactions. We suggest using STFS, Secure Token File System, to store the data in a secure and decentralized manner. We suggest using web3.js to create the user interface that will be seamlessly used by the users. And in the end, we suggest using Solidity for creating smart contracts that will help us to automate tasks such as tracking and rewarding the users. So using this framework, we plan to overcome the challenges that the existing systems face, because Polygon can be used for scalability and for lowering the transactional costs, STFS for immutable and secure storage, smart contracts using Solidity for automating tracking and incentivization programs, and user interface to facilitate seamless user interaction with the blockchain network. So the workflow of our particular framework will be as follows. There will be 4 roles in our blockchain framework. The producer is the one who is going to produce the e-waste and going to log that particular e-waste into our blockchain platform. The logistics, that is going to pick up the e-waste from the producer and drop it at the recycler's place. The recycler, that is going to perform necessary actions to properly dispose and or verify or recycle that particular e-waste item. And finally, the admin or the administrator, that is going to overlook or oversee this whole life cycle of that e-waste to make sure it is in compliance with the rules and regulations of the government and also the environmental regulations. So the flow will be after a particular e-waste electronic item is done being used, the owner can, as a producer, register into our blockchain platform and provide basic information such as the type of e-waste, the name, the quantity, whether it is hazardous or not, and log that particular e-waste into our platform. Then the logistics person will take up that e-waste from the producer, and while updating his or her location in the journey, drop it off or ship it at the recycler's place. The recycler, after examining the e-waste, will decide to take the necessary action to properly recycle or dispose that particular e-waste and mark it as recycled or disposed at the end. In the end, the administrator will verify the authenticity and ensure compliance with standards set by the government. So yeah, this is how the whole life cycle can be tracked from production till disposal of the e-waste. The expected benefits of our proposed framework are enhanced traceability of electronic devices, transparent and tamper-proof life cycle records, token-based reward mechanisms to promote responsible disposal, automated operations which will reduce manual intervention, and thus cost-effective and scalable to handle high transactional volumes. In conclusion, this study presents a comprehensive survey and a proposed framework for leveraging blockchain e-waste management. The framework integrates Polygon, STFS, Web3.js, and Solidity to improve traceability, efficiency, and stakeholder accountability. Our future work includes building and testing a working prototype with the proposed technologies. Thank you so much for all of your attention. I'm open to any questions that you have.
Thank you, Mrinal, for the presentation. Are there any questions? Any questions?
No questions from my side also.
All right. Thank you so much. Can you stop presenting?
Yes, thank you so much.
Thank you. Is there anyone else who missed the presentation and would like to present?
Hi, I'm Dr. Priya Singh. Actually, my timing for presentation is from 12:30. Can I present now?
12:30. I think it's in the next session, ma'am. You can't present in this meeting.
Okay. Okay, ma'am. No issue. Thank you.
Thank you so much. Right. With that, we come to the conclusion for the session for the day. I sincerely thank all our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during the 9th version and all the previous 8 versions of the conference. We'll be happy to have you in the 10th version in 2026 as well. All the presenters could be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the printer. The publication will be live within 6 months. Kindly cooperate with the team of ICTIS 2025. I also thank our session chair, Dr. Manoj Joshi, for chairing this session. Has a little token of appreciation from the team to you, sir. From the team of ICTIS and Global Knowledge Research Foundation and partners. Thank you for all of your valuable presence. I kindly request you all to switch on the camera for a quick snapshot of the virtual conference. Is that all? All right. Yes. Okay. I'll click the pic now. 1, 2, 3. Thank you so much, everyone. Have a nice day.
Thank you from my side also. All the
Thank you.
presenters were good enough and from with different domains. So my suggestion is that keep it up, go forward, make your models into reality. That is my wish to everybody, that they can implement whatever they've dreamed out in their research papers. Okay, so thank you from my side also.
Thank you so much, sir. Thank you for your kind words. Thank you.
Thank you, guys.